Welcome back to lesson 8.3. This is part 2, and now we're going to turn our attention to the inverse trig functions. There are 3 inverse trig functions. They are called the sine inverse, the cosine inverse, and the tangent inverse. First, I want you to take your calculator and look for these 3 buttons: sine inverse, cosine inverse, tangent inverse. They should be on your calculator. Usually these buttons are not the primary, but the secondary keys on a calculator. So the primary key would be sine, and printed right above it, sometimes in blue, sometimes in orange or yellow, is printed sine inverse. So that means it's a secondary key. And normally what you have to do on a calculator is you have to hit some kind of a second button or shift button in order to access the secondary keys. So first things first, make sure your calculator is in degree mode. If you don't know how to do that, look at the manual for your calculator, or you could probably even Google it and you can figure out how to make sure it's in degree mode, or you can ask me and I can help you to do that. Let's look at the first example. Find the measure of angle A and the measure of angle B to the nearest tenth. Well, I know that the cosine of angle A is 4/5. So to use the cosine inverse, I can now say that the measure of angle A is the cosine inverse of 4/5. Now what you would do on your calculator is you would type the second key or the shift key, cosine inverse, and then 4/5. Let me show you how to do that, at least on a TI-84. This is what you do. Second cosine inverse, and then 4 divided by 5, 4/5. Hit enter. And so we get 36.869896765. Well, we're going to take our degree measures and we're going to put them to the nearest degree. And so technically I have written here 36.9. It should say 37 degrees. So I would have written this, if I hadn't been paying attention, I would have written this as 37 degrees. Now, here's the cool thing. Since you have a right triangle, the acute angles are complementary, which means they add up to 90. So since I know angle A, let me just stick with 36.9 for now. Angle B is going to be 90 minus 36.9, and so that's 53.1 degrees. And now I know the angles in the triangle. Next example. Find the measure of angle A and the measure of angle B. Well, the sine of A is 6/12, and that's equal to 1/2. But that's one of our special trig constants. Hopefully, we've memorized that. That means that the measure of angle A is 30 degrees. You can even try typing sine inverse of 1 divided by 2 in your calculator, and it should give you 30 degrees. Example, find the unknown measures. Round lengths to the nearest hundredth and angle measures to the nearest degree. And so when they say round lengths, we're talking about sides. Well, we know 2 of the sides. So the length that we want to know is AC. And we know 1 of the angles, we want to know the other 2. And I'm going to present to you 2 different methods, 2 different ways of doing this problem. So let's focus our attention on method 1. I know 2 sides, the 2 legs of the right triangle, so I can use the Pythagorean theorem. So 7.5 squared plus 5 squared equals hypotenuse squared. So the square of the hypotenuse is 81.25, and that means the hypotenuse is the square root of that, which gives me this number. But I want all of my side lengths to the nearest hundredth. That's 2 decimal places, and so the hypotenuse is 9.01. Now that I have the hypotenuse, I'm going to find the measure of angle A by taking the tan inverse of opposite over adjacent. So the tangent inverse of 5 over 7.5 is 33.69. This I'm going to round to the nearest whole number, so that's 34 degrees. And since the acute angles and a right triangle are complementary. All I have to do to find angle B now is to take 90 minus 34, and I get 56. So that's the first approach. The second approach works like this. I know two of the sides, so instead of trying to find the hypotenuse right now, I'm going to find the angle. Now I know that the measure of angle A is the tan inverse of 5 over 7.5. 5 is opposite of A and 7.5 is adjacent. If I want to find the hypotenuse, what I do is I set up the sine of angle A, which would be opposite over hypotenuse. So the sine of angle A over 1 is equal to 5 over AC. Multiply the extremes, multiply the means. So that means AC times the sine of angle A is 5. And now I divide both sides by the sine of angle A. Now I use the substitution property. I already know that angle A is the tan inverse of 5 over 7.5. So I substitute that in, and I now have the hypotenuse is 5 over the sine of the tangent inverse of 5 over 7.5, and that again gives me 9.01. Let me show you how you would do that. 5 divided by the sine second tan inverse of 5 divided by 7.5. Two closing parentheses, one to close the tan inverse, one to close the sine. And there we go. So to the nearest hundredth, it's 9.01. Example, find the unknown measures, round lengths to the nearest hundredth, and angle measures to the nearest degree. So what's the question? What are the unknown measures from this picture? Well, we don't know EF, and we don't know FD. Also, we don't know angle D. But angle D is actually the first one we can find rather easily because we can use the complementary nature of the acute angles. So 90 minus 58 is 32. Now we know angle D. Now I'm going to use the sine because 14 is opposite the sine. FD is the side that I want to know. That's the hypotenuse. So the sine of 58 degrees over 1 is equal to 14 over FD. Multiply the extremes, multiply the means. FD times the sine of 58 equals 14. Divide both sides now by the sine of 58. And then just do your calculator. Use your calculator. 14 divided by the sine of 58 is 16 point that number. And since this is a side length, we're going to round to the hundredth. So that's 16.51. I'm going to leave it to you now to figure out side EF. You can do this a couple ways. You could use the tangent to find EF, or you could use the Pythagorean theorem because now we actually know what FD is. You'll probably get more accurate results if you use the tangent. Example, the coordinates of triangle JKL are, J is at -1, 2, K is at -1, -3. Find the side lengths to the nearest hundredth and the measures to the nearest degree. Well, the slope of JK is undefined and KL has a slope of 0. That means the two segments are perpendicular, and from definition of perpendicular, I know that angle K is 90 degrees. KL is slope 0, so the length is just the x value at L minus the x value at K. That's 4. JK is vertical, so the length is the y value at J minus the y value at K, and that's 5. Now to get the hypotenuse. Well, we're going to use the distance formula. x2 minus x1 plus y2 minus y1. Negative 4 squared plus 5 squared. The square root of 16 plus 25. And so that's the square root of 41, which is all this. But we're going to round to the nearest hundredth. And that 3 is not enough to round up the 0, so the hypotenuse is 6.40. Now, we know that this is 5 and this is 4. So angle L will be the tangent inverse of 5 over 4, which is 51.34 degrees. That 3 is not enough to round up the 51. So we're going to say that angle L is 51 degrees. And then finally, we use the complementary nature of the acute angles in a right triangle. J would be 90 minus 51, so J is 39 degrees. Remember, if I don't ever give you a picture, or if the textbook doesn't give you a picture, you need to draw a picture. Final example. An ancient pagan idol has been knocked down and leans against a vertical cliff. Someone's walking up the statue, and the grade of the statue is 80% if you walk up it. What angle does the statue form with the horizontal? What do I mean by the horizontal? I mean the ground. And so 80% is a slope. And so the way that we interpret the 80% is 80x feet over 100x feet. So we get a triangle that looks like this. And we're looking for angle 1 because that's the angle formed with the horizontal. So this is opposite and adjacent. That means the measure of angle 1 is the tan inverse of 80x over 100x, but the x's divide out, leaving 80 over 100, or 4/5. And that's about 38.65 degrees. We're just going to call that 39 degrees. So this false idol forms a 39-degree angle with the horizontal, with the ground. And that is the lesson on 8.3, solving right triangles. God bless you, wherever you are today.